Bismillahirrahmanirrahim. Okay, let's continue with our topic of solving quadratic equations. Previously, I had suggested to you that this is a generic quadratic equation. This is a kind of like where a and b and c represent some numbers, okay? And there are four ways to solve these. One was graphing. The second way was factoring. That's when you do that, and then you set these to be equal to 0, and or here, and then you solve it, right? And the third way was by completing the square. And finally, the fourth way was the quadratic formula. I shall write this enough times so by the time you actually get to it, you probably memorize it if you had not already. Opposite e plus or minus square root of b squared minus 4ac over 2a. So there are four ways we're going to learn, okay? So we had already talked about this, so today we should talk about this topic, completing the square. I gotta tell you, students don't like this, right? But you know, maybe if you're good at it, you'll like it. You never know. Okay, let's try it. So this is just another way of solving a quadratic equation. So let's take an example: x squared minus 12x plus 4 equals 0. Okay, we're going to try to solve this. Before I solve this, actually, I'm going to take more basic equations and from quadratic and try to solve those, because not all quadratics have to be done in those four ways. What if it's like this? So x squared equals 25, man. You're not going to factor that. You're not going to complete square. You're not going to graph that. You're not going to use the quadratic, right? You're just using take the square root of both sides like this, you know, and you're done. Take the square root of both sides, and you get x equals plus or minus 5. You're done. There are two answers: plus 5, minus 5. Okay, so let me just do some of these basic questions that require none of these fancy maneuvering of those four ways. So let's take this example: x squared equals 25. Okay. Now, this is a very basic quadratic equation. Now, to solve this, all you do is you just take the square root of both sides, okay? But when you take the square root of both sides, you have to take plus or minus. Like you have to take two square roots, plus of this minus. So the answer then becomes x is, square root of 25 is 5. This is going to be plus or minus 5. Because see, 5 squared will give you 25. And negative 5 squared will also give you 25, right? So this plus or minus is very important when you take square root of both of equations. So when you're taking equations and you're taking square root of the whole equations, you can do it. So what's the deal with taking the square root of both equations? Well, why not? You can multiply both equations by 3, and that's legitimate. You know, you can divide both equations by 12. That's legitimate. So why can't you take the square root? It's just, you know, it's just like an operation. Yeah? You follow? So simple equations like this: x squared equals 25. You don't have to do anything. You just have to take the square root of both sides, right? But the key thing again is to remember that you take plus or minus square root of both sides like that. So you get x is equal to plus or minus 5. You get two answers. Okay, now what if it's like this? What if it's like this? X minus 2 squared is 25. What do you do now? I know, same thing. You got something on the side, and there's a square over here, and this looks like a nice, you know, a perfect square. Are you kind of tempted to take the square root of both sides, right? Just like over here. All I did is added this 2. Okay, so yeah, that's what you do. You take the square root of both sides like this, plus or minus like that. Okay? Then you get, now you don't get, what do you get over here? When you do that, see, the square root negates this, just like over here, and the square root kind of just like made that square disappear, right? Because the square root is the opposite operation of a square. If you had 3x equals 12, you divided both sides by 3 to get the answer, because multiplication and division are opposite operations, so to speak, right? So same thing, square and square root are opposite operations. So if you take the square root, it makes this go away, so you get x minus 2. okay, equals plus or minus 25. Correct? So when you take the square root of both sides of this equation, okay, if you have something like this, when you take the square root of both sides like this, okay, then this goes away. Then you have x minus 2 equals, now you get 2 over here, positive and negative 5. You get to remember that. But so this is like two equations in one. What this is really saying is x minus 2 equals 5, or, okay, or x minus 2 equals negative 5. That's what that positive and negative means, or positive 5 or negative 5, okay? So you get two equations and you just separate them out. And then you add 2 to both sides, and then you get x equals 7. That's one answer. And add 2 to both sides, then you get x equals negative 3. So you get two answers. You know, if you substitute 7 and substitute negative 3 in here, then these will both work. Okay? Okay? So when you have simple equations like this, x squared equals 16, you don't do nothing fancy. You just take the square root of both sides like this. X equals plus or minus 4. And if you have x minus 3 squared equals 16, the same thing applies. You take the square root of both sides like this, but do plus or minus on this side. You get x minus 3 equals positive and negative 4. Square root of 16 is 4. And then you do change this into the two equations. X minus 3 equals 4. That's from this. And x minus 3 equals to negative 4. That's from the negative sign over there. And you solve it. X equals 7. X equals minus 1. You add 3 to both sides. Okay? So those are simple equations. Now, I started out with this example. X squared minus 12x plus 4 equals to 0. But here you can't like take the square root. See, how are you going to take the square root? You can't like distribute the squared symbol over here. You can't do that. It's harm. You can't. It's not allowed. You kind of wish though, right? It was like x squared equals 25. This was nice. This was good old days. You kind of take the square root over here. Take the square root over here. Okay? So the completing the square is a process. See? Completing the square is a process by where you transform this equation, okay, to something that looks like this, and with something over here, okay. So completing the square is a process where you take this and you change it to something that looks like this, because you know we've grown to like this now because we have something like this. You know, we can take the square root of both sides and you can solve it, right? So that's the idea behind completing the square. Completing the square is taking something that looks like this and changing it into something that looks like this, because then we can square root both sides, because it kind of feels cool to take square root of both sides of the equation. Okay? So that's kind of what we're going to do. Alright. The rationale behind completing the square is this. If you have a plus b squared, that's a plus b times a plus b. Remember this? Yeah, I can't forget that. You're trying to, weren't you? Okay, so a plus b squared, a plus b times a plus b. Right? Now this is a squared plus 2ab plus b squared. Okay? If you remember this. So a plus b squared is a squared plus 2ab plus b squared. Let me rewrite that, skipping the middle step here. A plus b squared is a squared plus 2ab plus b squared. Okay? So this is kind of like the good old days, okay? So what we're going to do is transform this into something that looks like this. Okay? Going backwards, because if you look at this, this can be turned into this, and this can be turned into this, right? For example, what I'm trying to say is, look, this is just foiled, right? From here to here. If you can do this, why can't you go do this? right? Of course, right? So that's the idea. Okay, but this formula is only for binomials that you're squaring. Okay, but this is not that. So, all right, watch this. Hopefully, in the end, it will all come together. You go, aha, I get it. So here's the thing: the way you complete the square, completing the square. Okay, completing the square. The way you do is this. Okay, first you have to make sure that this a is 1. Okay. Okay, in this case it is. If it's not, then you might want to get it to 1. So that's one thing. The second thing is you want to get rid of this 4. Okay. Now you can't get rid of it by just like erasing it there. It's not going to work. You can't do that. Okay. So you have to get rid of it means that you have to take it to the other side. Okay? You have to take this 4 to the other side. Okay. Because you need some working room. Okay. So you subtract 4 like this from both sides. Okay. When you do that, then you have this x squared minus 12x equals minus 4. Okay, now I've given myself some room. See, over here, giving myself some room. All right. So now see, what we're going to do is we're going to put something over here. Now I have not changed the equation at all. I have taken the 4 and put it on the other side, right? So now what I'm going to do is this. You're in a two-step process. You take this and you half it. This the b over here, the number over here, negative 12. You half it. So divide by 2, like this. Half that. So that's negative 6, right? And then when you do this, you square it. You square this thing, and you add it over there. That's 36. Now you have to be careful. See, all of this over here is just like scratch work. It's like, no, it's not part of the real equation. It's just like you're thinking. Okay, it's kind of like you're thinking. All right, but it's just kind of nice to write it out like that. But if you think about this, now you took half of 12, that's negative, and you squared it and you added over there. But you just can't add stuff to equations, right? You have to, if you add something to this side, you have to add it to the other side. So as long as you add something to both sides, you're cool. You can do that. You're not change the equality of the equation, right? So what do we do? Step 1 was to get rid of this 4. Take it to your side. That gives you over here. So the step 2 was to half this and then square it. To half negative 12, negative 6, and then square it and you add it to this side. And you added that same thing to the other side. Now students do all kind of funny stuff over here. It's just like crazy things. They make mistakes over here. They half it and then they put negative 6 over here or something like that. Or I don't know what the kind of stuff. Or they half this and they do this and they forget to put this over there. I mean, or all kinds of, like, you know, amazing, all kinds of mistakes. But don't do that. Half of this, put over here and square it and put over here and do it on both sides. Okay. And then see, then you have to understand something. Now this over here, what you just did is, this over here is very different from this, from what you started with. If you look at these two trinomials, x squared minus 12x plus 4, and you look at this one, x squared minus 12x plus 36, they are very different. Because this one is a square. This one is like this, a plus b squared. This one is not. Okay, this one's not a square. So, but this one is special. What you just did is you transformed something that was not so special into something that was special. Okay? How? Watch this. So now see, let me do this. You put the parentheses over here. and you put a square over there, and this is just x. Okay, then all you do is you bring this -6 down over here. The 6, not the 36. That's another potential mistake that students make. Put that over here, and you parentheses that, and you square that. And over here you simplify, you get 32. Now look what we did. We took a trinomial, okay, and we transformed it into a binomial that's squared like this. Okay, now if you square this, so x minus 6 squared, okay, that's a squared minus 2 times a times b, which is 6, plus b squared, which is -6 squared. If you do this, you see x squared minus 12x, okay, plus 36. Look at this. That's over here. That's over here. Okay, so what we did was we manipulated the equation into something that we like. Because what do we like about this? Well, what we like about this is that this kind of looks like this. X minus 2 squared equals 25, the one example I gave you, because now we can take the square root of both sides, right? That's what we have here. We can take the square root of both sides, or, you know, and that's really cool. So now what we do is we take the square root of both sides, plus or minus, right? Like this. So then we get, when you do that, you get x minus 6 equals plus or minus square root of 32. Now this does not factor out very nice and neatly. Okay, so but it does factor some. Okay, well, that's 16 times 2, right? 32 is 16 times 2. 30. Let me do it over here. Square root of 32. That's 16 times 2. Okay, now 16 can come out, and that's as a 4 square root of 2. Okay, so square root of 32 is 4 square root of 2. So let me simplify that and put it over here. Okay, we did that. So if you forgot how to do that, you Google it. You say simplifying radicals algebra, Google, enter. All right. So, and then you change this into 2, okay, or you can just add 6 to both sides. Okay, now this is not going to simplify, but so you add 6 to both sides like this. Okay, so x is going to equal to 6 plus or minus 4 times square root of 2. Now you understand there are two answers over here. Okay, one answer is 6 plus 4 square root of 2. The other answer is 6 minus 4 square root of 2, right? So you can write them as x equals that, or x equals this, or, you know, if you want to look cool, you start x equals 6 plus or minus square root of 4 square root of 2. That's the easier way of writing two numbers in one like this. Now you can't add these, that's why you can write the answers just like that. Okay? So this is the process of completing the square. Okay? So let's review this. Okay, let's see what we did. I'm going to the same problem. Okay, slowly. The first thing is we get rid of this 4 and you take it to the other side. Why? Because you know why. So you take the score 4 and take it to the other side. Then you have this. Kind of cool, right? Now, look, here's one mistake students do. They take the 4 and they make the wrong sign over there or something like that. Just be careful. All right. Now you have working room, right? So, and then what do we do? Okay, then you see you have over here, then you have this. Okay, take half of that, half of -12, then you get -6. Do it neatly. And then, so you don't make a mistake. And then you square it. Don't multiply it by 2. Don't put like 12 over there or something like that. Don't multiply by 2. You're just undoing yourself. You square it. Alright, so you square this. You get positive 36. And then you have to do that to both sides. Right? Now, then you recognize that this is going to be a square. So you write this. X. And then you just bring this over here. -6. Okay. And then you put that like that. And then you equals 32. And then you take the square root of both sides plus or minus over here like this. Okay? And this becomes x minus 6 equals plus or minus square root of 32 we said was 4 square root of 2. And then you add 6 to both sides. And then you get the answer. X is equal to 6 plus or minus 4 square root of 2. And ta-da, you're done. Okay? So this process is called completing the square. Okay? This is just another example of how you can solve quadratic equations. I want to do one more equation before I finish here, if that's okay. 2x squared plus 8x plus 14 equals I don't want to do this one actually because we're not quite ready yet. Let me try this one. Come on now, come on now. Okay, the example I want to do, in fact, let's do this one. 7t squared plus 28t plus 56 equals to 0. Okay? Okay, not that one either, actually, because I don't want to trick anybody. Okay, so let me do this one. Okay, let's pick this one. 4x squared minus 40x minus 12 equals 0. Alright, so we're going to do this by completing the square. So the first thing, the very first thing, is that you have to make sure that this is, the coefficient for this term is 1. Okay? You have to make sure it's 1. Well, it's not 1, right? So you can't just like erase this. You have to, what do? You divide the whole thing by 4. Divide everything by 4. Divide this by 4. Divide this by 4. Divide this by 4. And divide that by 4. Okay, so divide the whole thing by 4. So if you divide everything by 4, you get x squared minus 10x minus 3 equals 0. 0 divided by 4 is 0. Got it? Okay, now we're ready. That's the very first thing. The very first thing was to take care of that. And the very second thing is to get rid of that 3, right? Take this to the that side, right? Add 3 to both sides. I don't like to say take 3 to the other side, so you're calling it taxi and take it there. You're adding 3 to both sides. So you have x squared minus 10x equals 3. Okay, now you have working. And then if you recall, you take half of this. Half of negative 10 is negative 5. And then you square that, and that's 25. So you take half of this, and then you square this, okay? But you can't add 25 to this side and not add 25 to the other side, because that won't be fair, right? And that won't be right either. So you have to, whatever you do in one side of the equation, you have to do to both sides of the equation. So we did that. Half of this, and you square it. And then you change this to x minus 5, and then that's the square now, equals to 28, right? And then you take square root of both sides, you get x minus 5 equals plus or minus square root of 28. Okay, that's 4 times 7, right? So that's plus or minus 2 square root of 7. Okay, and then you add 5 to both sides, and you're done. So x is going to be equal to 5 plus or minus 2 square root of 7. Okay, and that's it. You can't add these two together, right? So those are that's the answer. So we'll inshallah do some more trickier problems with all of these in the end, once we have learned the 4 ways of solving quadratic equations. So there are 4 ways to solve this as a review, and before I finish, First is by graphing. The second one is by factoring. The third way is by completing the square. Okay, this is where we're making that something that looks like this to something that looks like this and taking the square root of both sides. And this is like factoring. And the last way, of course, is the quadratic formula. And we shall talk about this, in fact, next time. We talked about factoring, we talked about completing the square. Next time we shall talk about the quadratic formula, and the last thing we'll do is by graphing. Until then, salatu wassalamu ala rasulillah wa rahmatullahi wa barakatuh. Assalamu alaikum.